So we again have a matrix of dimension m cross n. Okay. The question is that this is row wise as well as column wise sorted matrix. By this, the intention is that every row is sorted and every column is also sorted. Okay, they are individually sorted. Okay, so let's take an example: 10, 20, 30, 40, 15, 25, 35, 45, 27, 29, 37, 48, and then 32, 33, 39, and 50. So there is a matrix which is row wise and column wise sorted. Do you see that this qualifies to be a right test case? Do you see that every row and column is sorted here? Yes or no? Look at every row one by one. You will see that every row is sorted. And also look at every column one by one. You will see that every column is also sorted. Okay? I think all of you should be able to see that. Now the question is that this obviously is your input. Apart from that, there is one more input, which is an integer target. So let's say your target is 29. What you have to do is, if this target is present in the matrix, if it is present, then return true, and if it is not present, then return false. That's it. So if something is, if the given target is present in the matrix, you're supposed to return true or you return false. That's it. Nothing else. So tell me, how do I solve it? What will be the brute force approach? Brute force approach is very simple. You simply write two for loops, scan the entire matrix and check whether a particular cell contains this target or not. If it contains, return true. If it doesn't contain, return false, right? Can we do something better? I think some of you might have studied some techniques to do it in a better manner. We will do like binary search, yes. So how many of you know something about binary search, right? Yes, binary search is quite applicable here. And one of you is asking me to start from top right. Okay, so I think that is the best thing that we can do. But before that, binary search can very well be applicable here. And we'll understand that why, because whenever your search space is sorted, you can use binary search, right? So every row is sorted. So you can search for this target in this row. If you did not get it, then search in this row. If you did not get it, then search in this row, and so on and on. You can also search column by column, apply binary search column by column, and then get your job done. Okay, what will be the complexity of this binary search based approach according to you? Is it n plus m? Think again. So the complexity of binary search is logarithmic, right? So like if you take a look at any row, the number of elements in any row will be number of columns, right? So if you search anything in a row, the time taken will be log n. Okay, and because you are doing it across all these m rows, your overall time complexity will be order of m into log n. If you do it column by column, then in every column there are n elements. In every column there are m elements. So the complexity for every column is this, and there are n such columns. So you can solve it in either order m log n time or n log n time, which is better than order. So this is better than order of m into n. So binary search does something better. Okay. Okay. Can I do better than binary search? Because binary search is taking me m log n or n log m time. So can I do better than that? Okay. So Karthikeya is saying, can we compare an element by every element below and to right and shift to element which is greater but smaller than target? That's excellent. So that is the intuition. So there is a very interesting thing that you can see here. Let's say you are trying to search for a target called 29. Okay. So you know what you can do. You can start searching from any end. So this matrix has 4 corners. Okay. But some corners are very, very special, and you will realize why. I'm giving example of one corner. Let's focus on this corner. So let's say you start your journey from this corner. So basically here, this is lying in I equals to 0th row, and column is n minus 1, right? So you will start your journey from this coordinate, which is 0, n minus 1. Now what you will do is that you will compare your target with this element. So when you compare your target with this element, then three kinds of things can happen. First thing is that this happens to be equal to your target. If this happens to be equal to your target, then you return. You can also return the coordinate. If the question demands for the coordinates of the target, you can return that instantaneous coordinates and then your job is done, right? So that was the first thing. Second thing that can happen is that your target is greater. So let's say you were searching for something like 39. Sorry, not 39, something like 50, okay? So let's say your target happens to be greater than it, then can it ever happen that this target lies in the same row and before 40? Can it ever happen? It can never happen, right? Because every row is sorted, okay? So what is the first case? If I see that my target is greater than wherever I am, so I am at I comma j. So if my target is greater than wherever I am, then I should move down. Moving down means that whenever you move down, then you scrap this entire row, correct? On the other hand, so basically I'm writing move down. Second thing is that your target could also be smaller than your matrix Ij, like it is happening for this case. If my target is smaller than this particular element, then I can say that, hey, this entire column is useless for me. And that way I scrap this entire column and then I move left. So only this much part is useful to me now. Previously, when I was moving down, then this much part was useful. And now when I am moving left, then this much part is useful. So when your target is greater, then you are moving down. And when your target is smaller, then you are moving back. So, you know, that way it becomes very easy for me. So we will do one dry run. So let's say you were searching 29. You compare it with 40 and you find that this is smaller than 40. So you come here, you move here. Now you compare 29 with this target and you find that 29 is smaller than this target. So again, nothing below can be useful. So again, you come here. Now again, you compare this thing with 20. This is greater than 20. So nothing in the left can be 29 because everything in the left is sorted. So it will be all smaller. Now you will come down. Now again, you compare this with this, you come here. Here you see that the target and the value are equal. So you return this and that's how you get your job done. So do you see how this approach is going to operate in here, right? Yeah. And why this is operating? Because at any point, the two moves that I had, those both moves are pointing to two different categories. And those two different categories are fortunately these two things only, okay? So sometimes you either move here or you move here. And this is how you get to have your job done. 29 can be on right of 25. Yes, 29 can be there on the right of 25. But what would happen here is that the reason you came back from here, the reason you came back from 30 was because everything below 30 was greater. Everything below 30 was greater. That is the reason you had scrapped it, correct? So now if you go back to that again, that means you are dishonoring the step that you had made before. So that is the reason. So anything that you have scrapped it for a particular reason, okay? So no need to go back at that place again. So if you scrap this column, you completely come back, this is entirely gone. If you scrap this row, this is completely gone, you come down, this is how you go ahead and get to your solution. Certain times what can happen is that, let's say you were searching for something like 25. If you were searching for something like 25, let's say now you came here, now you see that your target again is smaller than this. So your target cannot lie to your downside, it would definitely lie in your left side, okay? So now you will go to your left side and now you will come here. Now again you compare this with this and now you will again see that this thing is smaller than your target, so it cannot be down, it will be left. So whenever you see that searching for something you came out of this grid, you either came out here or you came out here, that means you could not find it at all. If you could not find it at all, then you return -1 or whatever the question demands you to return. So in this question, I started from this corner and my moves were either this or this, right? Tell me one thing, was it possible for me to start from a point like this? Could I start from here? Bottom left, I'll come to bottom left, but do you feel I can start from there? You know, I cannot start from here. Why I cannot start from here is because Let's say you were searching for a value which was like 44. Now 44 is smaller than this 50, and everything in the left is also smaller than this, and everything in up is also smaller than this. So you will not be able to determine that if this thing is smaller, whether you discard this row or you discard this column. So you will not be able to decide whether you should go up or whether you should go left, right? So this is a confusing starting point. You cannot start from there. But can I start from here? Yes, I can start from here also, because if something is smaller, then I'll climb up, and if something is greater, then I'll go here. So if something is smaller, you scrap this entire row, and if that something which is target is greater, then you scrap this entire column. And similarly, you will realize you cannot start from here also, because whether you move right or you move like this, the values that you would be getting would be greater only. So these are the 2 points which help me perform these categorizations, help me map these categorizations to the 2 different moves. Okay, that is the reason one of those would be best to take. Okay, if I have to code this approach, before that you tell me what will be the time complexity of this. There are m rows and n columns. So let's try to understand that. What is happening is your moves from any point are either 1 unit move in horizontal line or 1 unit move in vertical line, right? Now what can happen is that if you have your if your horizontal moves have been equal to, let's say, n, that means you would be out. If your horizontal moves have been equal to m, then also you would be out, right? So what would happen is that every time you take any move, either your horizontal moves increases or your vertical moves increases. In the worst case, what could happen was that your path was something like this, zigzag, in which you had taken almost order m and order n horizontal and vertical moves. So in the worst case, the number of moves would have been m plus n. Okay, so that would be your worst case time complexity. Do you get the worst case? How that would be the worst case? You are, let's say, searching for something which is in the opposite corner, and let's say the path that your algorithm made you take was like this. Otherwise, if let's say you happen to take this path or this path, which could be possible, right? So in that case, it would be order of min of m comma n or whatsoever, something like that. So what you can do is you can have I and j, and you can return coordinates also. If the question demands for the coordinates of the target, if it is present. So you start from there, you fix your I and j as this. I'm not going to write it again. And then as long as your I happens to be smaller than n, because your I is always increasing. Moving down means I will increase, okay? And your j happens to be greater than equals to 0. Your j is always decreasing. Moving back in column means your column number decreases. So as long as you are within this particular maze area, what you can do is you just compare. If you see that target happens to be greater than matrix of ij. If target happens to be greater than matrix of ij, then you will go down, and going down means I plus plus. Else if the target happens to be smaller, then you will go left. Going left means j minus minus. Else it means that else you will simply break. And once you break, then whatever is your instantaneous value of ij, else means that that particular thing is your value. Okay, if that particular thing is your value, then you can just return those coordinates, and that would correspond to your answer.